Welcome to ECO Ask Why, a podcast that dives into industrial manufacturing topics and spotlights the heroes that keep America running. I'm your host, Chris Granger, and on this podcast, we do not cover the latest features and benefits on products that come to market. Instead, we focus on advice and insight from the top minds of industry because people and ideas will be how America remains number one in manufacturing in the world. Welcome to ECO Ask Why. I'm your host, Chris Granger, and I'm looking forward to spending some time with you today. And we're continuing our look into the heart of industrial manufacturing. And for us, that's the industrial control panel itself. So we're really, the last episode, we took a kind of one-on-one overview, if you will, of what's inside an industrial control panel, what to look at, what are the primary components. And for this conversation today, what we're going to try to do is take it one step further, because we really want you to feel extremely comfortable when you walk up to an industrial control panel. And for this, let's focus on safety through overcurrent and motor protection. Okay, so when you think about industrial control panel design, electrical safety and long-term reliability depend on effective protection strategies. That's what it is. And two of the most critical areas to think about in terms of protection are overcurrent safety, okay, and motor protection, because these are so essential for preventing damage, to prevent downtime, and to keep people safe from the hazards that exist within industrial manufacturing. So we're going to explore how traditional protective methods have evolved into now intelligent systems that enhance both safety and operational insights. And I think that's what you're going to find most interesting as we dive into this, is like, how can we start learning data and using data from our control systems to make better decisions. Okay. So again, at Electrical Equipment Company, we're passionate here, okay, about helping manufacturers, OEMs, and maintenance teams, all of that, understand these concepts. So again, if you're designing your first panel, hey, this could be great for you. Or if you're just refining a complex automation system, some of this may be good reminders as well, because our focus is always on helping you make the most informed decisions and ultimately prioritize safety and performance within your facility. Okay, so let's start thinking about overcurrent safety really around two areas: fuses and circuit breakers. Okay. Now, just as a reminder, overcurrent, that really happens when electrical current exceeds the rated capacity of the equipment or the conductors that it's working with, right? And what does excessive current do? Well, it generates heat. It can increase the risk of fire. Equipment can fail. Excessive current can even create personal injury. So fuses and circuit breakers, they are the first line of defense, if you will, against these conditions. And they're going to interrupt that current before damage can occur. And that's the whole key with all this, right? So inside in a typical industrial control panel, incoming power is routed through a main disconnect, okay? And that disconnect is just really doing that. It's disconnecting the line from the rest of the panel. That's what it does. Then from there, the power is routed through fuses and circuit breakers. And this arrangement allows power to safely be isolated. So like if you're performing maintenance, you want to be able to do that without a risk of getting hurt, right? So this is what this does. And it also, when designed correctly, gives you protection against short circuit. We're going to talk about that. And overload conditions. So there are two separate conditions right there. You have short circuit and overload. So now, what's the difference between the two? Well, a short circuit condition occurs when current traveling along an unintended path of very low resistance, right? So really what happens here is you have a surge of current, and that can instantly damage, and I mean damage, lots of stuff. Conductors, components, you can see wires just getting blown up. You can see all sorts of things getting damaged. So you have protective devices in line, like fuses and circuit breakers, to respond when this condition occurs, to break that current and prevent the extensive damage that's there. So that's a short circuit. Now, overload is a little bit different. Overload occurs when the equipment is operating above its rated current. And here's the difference: for an extended period of time. Because think about a short. Short is pretty instantaneously, like it's going to surge right now. Overloads build gradually, and quite often it builds heat gradually. So overload devices use an inverse time response, and they're allowing short bursts of current of starting up, but tripping the condition, tripping if the condition persists long enough to hurt the equipment. So there's a difference there. So you got to figure out, if you got both of those conditions that you're trying to protect against, what's the best mechanism and way in order to do that? Well, that's when you have to start making decisions between fuses and circuit breakers. And it's not a one versus the other. Quite often it's a both and situation, because fuses and circuit breakers, they essentially serve the same purpose. They want to interrupt the current. That's it. They want to interrupt it when that condition exists. But the way they function in certain situations, they're different and they serve differently. And understanding this distinction is the key to designing safe and reliable control panels. So fuses at the basic fundamental level use a thin filament enclosed in an insulating material. And when it's exposed to excessive current, those filaments heat up and they melt. They permanently break the circuit. That's why when a fuse blows, what do you have to do? You don't go and reset a fuse. You pull a fuse out and put a new fuse in, right? That's how it works, because it's a permanent disconnect. And the advantages of a fuse, quite often, they're less expensive, and they react to extremely fast fault conditions. So if you're thinking about trying to protect sensitive electronics or circuits that really require this level of precise, fast-acting decision-making on overcurrent, fuses are where you want to go. Now, there's with every one decision, you have another type of implication as well. So what it is? Well, one limitation with fuses is they are really a single-use device. Right? You're not going to reuse a fuse, right? Once it's blown, it's blown. It has to be replaced. And if the wrong replacement, like maybe if you have the wrong fuse type or the wrong class installed, then you could be setting yourself up for damage, because at that point, you've circumvented the purpose of the fuse. Okay. And conversely, if you don't put maybe put too low rating in, you may be blowing fuses more frequently, right? And then this is something to consider. So you have to be careful, because fuses can also blow frequently if you have a lot of high inrush or startups on the circuit. So not that you can't use them, but it needs to be taken into mind when designing the right type of fuse, right? And that's a whole podcast on itself on fuse selection, but this gives you a high level overview. Then for your circuit breakers, think of that more as the mechanical device. Okay, so the circuit breaker is using a magnet and thermal elements. Often it's a solenoid or bimetallic strip. And really, what is it trying to do? Interrupt the circuit. That's it. It literally is, the name is in the naming convention, circuit breaker, right? So when excessive current flows, the strip bends and it triggers a solenoid, and next thing you know, that breaker trips. And the advantage of a circuit breaker is pretty simple when you think about it. Breakers can be reset. Think about when a circuit breaker trips at your house. What do? You don't just panic and never have power again. No, you reset the breaker, right? You don't have to pull it out or anything like that. You can just literally go and reset it. So this avoids the need for quite often replacements. And you can adjust these breakers for different trip curves and time delays. So they can help you when you're designing systems that experience high inrush currents, like a motor circuit. This is very suitable here, because the breaker can be adjusted to handle and to not interrupt that inrush current. And they also include lots of additional features that you can get on circuit breakers these days for arc fault or ground fault protection. You maybe heard like ground fault protection receptacles in your home, but you can have ground fault type of breakers as well. So again, with every pro, there's a associated con, right? And I guess the only limitation, well, the primary limitation to consider when you look at the circuit breakers is they generally respond slower than fuses will. Okay, they can also be more expensive. A breaker is more expensive than a fuse, so just have to keep that in mind. So if you're looking for stuff that needs a fast response, circuit breaker, you may need to have some fuse types of engineering in that process as well. But their reusability and flexibility, man, that they're really, it often offsets the higher initial cost when you're thinking about long-term applications. So selecting between the two really comes down to considering the application sensitivity and the operating profile of what of what's installed, right? So if you have systems with delicate electronics or fast reacting components, you may want to consider having the right fuses designed for that application for precision and quick response. If you have systems or circuits with high inrush currents requiring frequent resets, you may want to consider a circuit breaker there. And ultimately, the correct selection ensures that overcurrent protection operates as intended, because you want to preserve the equipment. You want to maintain the uptime, right? You want to keep everybody safe and operating there correctly, right? So again, eco right here is if this is where we step in and we help. We have engineers that regularly have these conversations to help you navigate these trade-offs and to start thinking about the right protection method for your specific application. And obviously, you have to take in consideration cost and maintenance and long-term reliability. So if we're looking at a single control panel to a full plant modernization, we always are trying to help you make the safe decision, the smart decision, and one that's sustainable as well. Okay, so that kind of gives us a breakdown between overload, short circuit protection, and fuses and circuit breakers. Now, let's transition. Let's now think about the core of motor protection. Okay, and you're going to hear this quite often. You'll go to an industrial control panel, you open up, you'll see overload relays, because at the end of the day, quite often electric motors are the backbone of industrial operations. They just are. And so you want to safeguard them, right? And this is a big part of my career for a long time with eco. It's just when we were doing motor service was understanding the motor circuit. So this is something that I've seen come for just so far, so fast, and it's incredible to see the advancements in technology. These overload relays are incredible. And a motor starter, when you think about a motor starter, you really have two primary components of a motor starter. You have a contactor, okay, and that's used for switching. And then you have an overload relay, and that's used for protection. And without the relay, the motor starter can't protect the equipment. Right at that point, whatever happens, that motor that's at the end of that line is open and susceptible to whatever conditions that come across that motor circuit, and that can be very damaging. It could cost you a lot of downtime. Okay, so let's just think about when we open up a lot of control panels, particularly in older manufacturing, you're going to see traditional overload relays, and typically they're probably thermal. Okay, so you'll see them as like they're called thermal overload relays. Usually has like a bimetallic design, and they've been used for a long time. Why? Because they're simple and they're effective. They are, right, and they're also very cost effective. They respond to heat generated by what? The excessive current, and they trip the circuit to prevent the motor from overheating. So when you start thinking about this a little bit deeper, they're reliable for basic protection for sure. They definitely are, but they have their limits. Let's just be honest. Quite often they can respond after a fault occurs. Okay, so it's not giving you that immediate, short circuit the way that we typically would think. So it doesn't give you a lot of a standard thermal relay. It's not going to give you any type of predictability, right? They lack diagnostic capability as well, because they're not going to tell you why. They're just going to tell you that it tripped. That's it. So advanced motor control must be handled externally. So this is going to require additional hardware or equipment or programming or things like that to give you that insight. So the industry recognized that this was a gap. Like it worked for a long time. And these things are still out there, y'all. I mean, don't think that there's no, bimetallic overloads out there. They still exist. But we recognized there was a need for evolution. Okay. And this evolution took us to intelligent, or you may even hear them called smart overload relays. Okay. Because we recognized that industry was trending towards connectivity, huge component, and predictability. Like the predictive maintenance is a big deal. So a lot of that, those efforts along those lanes led to intelligent electronic overload relays. Okay, so these devices combine the protection that we're looking for along with communication and analytics in one package. So it's really cool when you start thinking about it, because predictive and diagnostic capabilities are huge. And smart overload relays, what they can do is detect abnormal operation conditions early on. Okay, that's pretty cool. It does that with by monitoring phase imbalance or ground faults or sustained overloads, and those items account for nearly half of all motor failures. They just do. So they monitor voltage, current, temperature. They can even have relays out there now, different types of relays and points that can monitor vibration, and they can give you real-time insight into your motor health. So start thinking about stuff that you can get out of these devices. You can look at trip causes and event history. Go back and look at that catalog. You can look at how often are you operating the equipment and how often are you starting it up. So operation hours and start counts, right? You can see what the faults were. Like, what were the last 5 faults for this piece of equipment? Was it under voltage? Did something jam up on it? Was it an overload, right? And it gives you early alerts for mechanical issues, like as a low load or dry pump conditions. I'm telling you, these things are incredible. And this visibility allows your maintenance team to identify, and here's the important part, correct issues before they escalate, so you can minimize that unplanned downtime and exceed that motor life. Really cool stuff. Okay, so now let's talk about how we can enhance motor protection with these relays, because these relays often include programmable alarm thresholds and automated restart logic, as well as load monitoring. So think about it this way. These capabilities help you, the operators, manage multiple motors efficiently and hopefully prevent some unnecessary trips. There's nothing worse than having to go restart a motor and you're not sure why, right? So let's prevent that. And then let's start balancing these systems overall to have better performance. And then when you have systems like, or applications rather, like pumping systems with the right type of smart overload relay, you can detect low current in these areas, which is really valuable, because it could help you prevent conditions like dry running or deadheading your pumps that can cause severe mechanical damage, right? So these early alerts will give you and your maintenance teams time to intervene before that thing fails. And once it fails, at that point, the work has to be done. Downtime, it becomes a reality, and you have to move into it, okay? So another kind of cool part with these smart motor overload relays is the real-time data and integration that it comes with. So through network connectivity, we've talked about the importance of that on EcoSY for a long time. These intelligent relays can give you operating data to your systems that you're executing your manufacturing plant in, and this allows you and your plant personnel to monitor performance. Maybe you want to look at your energy usage as well. And here's the trick: in real time. Like, we're not just looking back; like, we're looking at what's happening now, and you can start forecasting forward. And when you start doing that, and you integrate with your modern automation systems, you can really start enhancing remote diagnostics, continuous improvement, and energy efficiency initiatives out there. So when you start leveraging this side of data and these components within the industrial control panel, you can start strengthening safety, you can have better performance, and really, at the end of the day, increase your overall equipment effectiveness. We hear about OEE all the time, right? You can do all this without sacrificing any reliability. So I'm telling you, this stuff's out there now is absolutely unbelievable. It's pretty cool. And at the end of the day, we recognize at ECO that you are continuing to modernize. You're continuing to prioritize safety, and you're continuing to look forward to how you can be more predictive in nature, right? Because they cannot be goals that we're not focusing on. We have to focus on them to remain competitive in the markets that we serve. So when we focus on reliable overcurrent protection and we get that right, like we get the breakers and the fuses designed correctly, you're really building a strong foundation. Okay, a strong foundation to ensure that you're protecting your assets. And then when you start integrating intelligent motor protection systems, man, you're taking it to the next level, because then you're starting to bring foresight and diagnostics and smarter control to the forefront of your design. So we're not just talking about new installation here as well. This could be retrofits. We do it all the time. So it could be existing equipment as well as new equipment, and bring this new technology together, because it's all about prioritizing protection to really, it's not only about compliance and uptime, but it's also think about the long-term health of the equipment that you're counting on to keep your production running. And we recognize that's a big deal. I mean, someone who worked in the service industry for a long time, I know how stressful unplanned downtime can be to any organization. So if we can do things on the front end to prevent that in areas that we can control, we want to do that. And that's what this is all about. And we love at Electrical Equipment Company talking control panels. We just do. I'm saying, from the novice to the expert, we will meet you where you are. We'll offer as much insight as we possibly can to help you along the way, whether it's design guidance or technical expertise. We're here to make that process so much easier for you. Okay, so look, reach out to us. There will be links in the show notes and all that stuff for ways to reach out to us, to connect with us. Again, we have our labs and all our geographies. So if you want to come talk directly or test some technology, we'd love to do that. If you'd like for us just to come take a look at your industrial control panels and understand what your current install base is, so we can help you make more informed decisions on particular areas of high risk or areas that you just really need to put as much emphasis on as possible to do everything that you can to reduce that downtime, we're here to help. We have experts. We have just a wonderful team. So again, if you're listening to ECO SY and you're in our service area, reach out. We would love to talk to you about this and see how we can come alongside you to identify areas that we can help improve, and particularly when it comes on the motor circuit and protecting your industrial control panels. So hopefully you guys are enjoying these. We enjoy putting this together because we recognize everybody's at different stages in their journey, right? They just are. So again, industrial control panels are such a key component. We don't just want to fly by it. We want to take the time to unpack these at length to give you the insight so that you can build your confidence when you're walking it through your facility up to an industrial control panel, to better understand what you're looking at, and to ultimately do it in a safe manner. All right. So again, thank you so much for listening to ECO Ask Why. If you wouldn't mind, just share this stuff out with others, particularly others that you think they're in their journey that would be interested in these topics. We know this is not for everybody, but for the ones that find interest here, we're really hopeful that we're bringing you value and helping you just build your confidence and your skill sets up so that you can just do more in the industry. Again, if you have questions or want to talk further, reach out to us. We'd love to hear from you. So all that, you can find us at ecoonline.com. That's how you connect with us there. Obviously, we have the podcast. We have all our resources. We have our shopping, all the stuff from an online shopping experience. So you can even go look at some of these overloads and start comparing them side by side. We'll have links to all that stuff as well. So check it out. All right. So I hope you guys have a great day. Thank you so much for listening, for hanging out with us. And just remember to keep asking why. Thank you for listening to ECO Ask Why.
This show is supported ad-free by Electrical Equipment Company. ECO is redefining the expectations of an electrical distributor by placing people and ideas before products. Please subscribe and share with your colleagues and friends. Also, leave comments, feedback, and any new topics that you would like to hear. To learn more or to share your insights, visit ecosy.com. That's EECOASKSWHY.com.